Alright, this video is going to be a review on the stoichiometry unit and mostly looking at the different conversions and how to do those. So the first types of conversions we're going to do are all one step. So one-step conversions are grams to moles of the same element, moles to grams of the same element, moles to molecules of the same element, or mole to mole of a different element. So the first one we're going to do is grams to moles. And for example, if you have 2.3 grams of Ca, how many moles of Ca would that be? So you start by writing what you're given, 2.3 grams Ca. You need to set up your conversion. Because you're starting with grams of Ca, you have to match your units diagonal, so grams of Ca. And grams is always going to be in a conversion to 1 mole of that same element or compound. And so the grams is going to come from the periodic table. Mass of Ca is 40.1. So you do your quick conversion, 2.3 times 1 divided by 40.1. And it's 0.057 would be the correct answer with the correct number of sig figs. And your unit is mole Ca. If we wanted to go the other way, so going from moles to grams, you start by writing what you're given. In this case I said 3.5 moles of Ca. Set up your conversion. What you're given has to match diagonal, so mole Ca is what you're given, so mole Ca has to go on the bottom. It's always going to be 1 mole 2 grams. And again, the mass of Ca is 40.1. So in this case, you will take 3.5 times 40.1 divided by 1, and your answer is 140. Correct number of sig figs, and your unit is grams of Ca. If we're going moles to molecules, you again, and this is of the same element, you start by writing what you're given. This one is 3.5 moles of Ca. Set up your conversion. If moles of Ca is what you're given, that's what has to go diagonal. Mole Ca, so that would have to go on the bottom. And we're trying to get to molecules, and the conversion that you know is 1 mole equals 6.02 times 10 to the 23rd molecules. So it's just one step. So you would go 3.5 times 6.02 E23 divided by 1. And you want 2 sig figs, so the answer would be 2.1 E24, which is 2.1 times 10 to the 24th power. And that is, the unit is molecules of Ca. Mole to mole, this is a little bit different because you have to have a balanced equation that you're going by, so I'm going to erase what we did up here so I can write out a balanced equation. So let's say our equation is 2H2 plus O2 gives you 2H2O. So 3.5 moles of O2 equals how many moles of H2O? So this is where you're going to use your mole to mole ratio, but you start by writing what you're given. 3.5 moles O2. And because we're trying to get to a different element and we're already in moles, you use your mole to mole ratio. You need moles of O2 on the bottom, and you need moles of what you're trying to get to on top. In this case, it's moles H2O. Whenever you have moles over moles, you need to use the coefficients as your numbers. So if you look in the balanced equation, this coefficient in front of H2O is 2, so that means a 2 is going to go right there. and in front of the O2 there's no coefficient, which means that would be a 1. So 2 to 1. So you would go 3.5 times 2 divided by 1, and that is 7.0. Your unit is mole H2O. The next set of conversions are going to be two-step conversions. And these require a balanced equation, so we're going to use what I wrote before, 2H2 plus O2 gives you 2H2O. So first question is grams to moles of a different element. 3.75 grams of H2, that's your given, will produce how many moles of H2O? So that's what you're trying to get to. So you start by writing what you're given, 3.75 grams H2. Set up your conversion. What you start with is grams, so you have to match the unit diagonal, grams H2. Whenever you have grams, it's always going to be grams per 1 mole of that substance. Grams we get from the periodic table, so the mass of H is 1, mass of H2 would be 2.0. So this now is in moles of H2. It is asking for moles of H2O, so we need to do one more step. Moles H2 is on top, so we need to match it diagonal. Moles H2 would go on the bottom. And we are trying to get to moles of H2O. So here we have moles over moles, and when you have moles over moles, you are going to use your coefficients to figure out the numbers. So if you look at the balanced equation, the coefficient in front of H2O is 2, and so therefore we would have a 2 here, and the coefficient in front of H2 is also 2, so we have a 2 on the bottom. You would take 3.75 times 1 times 2 divided by 2 times 2. And make sure you're using your parentheses. With 3 sig figs, the final answer would be 1.88. And your unit is moles H2O. If we are going in the other direction, moles to grams, again of a different element, it says how many grams of O2, so how many, that's what we're trying to get to, were produced by 6.3 moles of O2. How many grams? We need to change this. How many grams of H2O? Were produced by 6.3 moles of O2. So you start by writing what you're given, 6.3 moles of O2. Set up your conversion. What you start with has to go on the bottom, so mole O2 on the bottom. Here we need to do a mole to mole ratio. So we need to go from moles O2 to moles H2O so that we can finally get to grams of H2O. When you have moles over moles, you use your coefficients. And your coefficient in front of H2O is a 2 from your balanced equation. And coefficient in front of the O2 would be 1. From here, you set up one last conversion. Moles H2O is on top, so it needs to go down on the bottom. And we are trying to get to grams of H2O. Whenever you have grams, it's always grams per 1 mole. And the mass is going to be hydrogen, the mass of hydrogen plus oxygen. So hydrogen is 1 and oxygen is 16. So your mass is going to be 18.0 grams H2O. When you multiply this, you're going to go 6.3 times 2 times 18 and divided you you should get 226.8. And rounded to 2 sig figs would be 230 grams H2O. Our last type of conversions are the 3-step. And again, with these, you need a balanced equation, so we're going to use the same one we've been using. 2H2 plus O2 gives you 2H2O. And so these are the longest ones you're going to do, grams to grams of a different element. So how many grams of H2O, so how many, that's asking for your final product, are produced if you start with 23.2 grams of oxygen. So you start by writing what you're given. (23.2 grams oxygen). However, if you look up in your equation, oxygen is not just O, it's O2, so you have to have your O2. And we're trying to get 2 grams of H2O. So first step is to convert it to moles. Match your units diagonal, so it's going to be grams O2. Grams is always to 1 mole of that substance. Oxygen is 16 grams, so O2 would be 32.0 grams. Your next step is to convert it to the other substance. So you're going to have a mole to mole ratio. Mole O2 has to go on the bottom, and what you're trying to get to goes on top, so mole H2O. When you have moles over moles, you have to look at your coefficients. The coefficients in the balanced equation for H2O is 2. Coefficient in front of O2 is 1. And then now our last step is to get back to grams. So you have to match your units diagonal, so mole O2 has to go on the bottom, or mole H2O, I'm sorry, to grams H2O. And it's always going to be the mass per 1 mole. So remember, H2O, the mass is going to be H plus O, which before we said was 18.0 grams. So when you type this in, you are going to need to, if you are typing it all in at once, parentheses, 23.2 times 1 times 2 times 18.0. All of that divided by, in parentheses, 32.0 times 1 times 1 equals, the whole thing should equal 26.1 grams H2O. Next thing we're going to look at is limiting reactants, and this is actually question 16 on your review. If 4.54 grams of Na and 21.45 grams of zinc chlorate react, which is the limiting reactant? So in this problem, because question 17 is asking about zinc, we're only worried about the amount of zinc produced. So you're given the balanced equation, which is zinc chlorate plus 2Na Okay, so there's your balanced equation. With limiting reactant, you need to set up 2 equations and figure out which one produces the smaller amount of product. So you're starting with 4.56 grams of Na for one of your equations, and you're starting with the other reactant for your other equation. However, both of them are going to, you're going to convert to grams of zinc. So I'm not going to set all of these up, but you're going to convert from 4.56 grams of Na, and you follow it just like we did on the last conversion, and you're going to convert it all the way to grams of zinc. So that's one equation. You're going to do your other equation too, which is 21.45 grams of ZnClO3 convert it all the way to grams of zinc. Now once you do those conversions, you should have the first one, your 4.56 grams of sodium, will produce 6.48 grams of zinc, and your second one will produce 6.036 grams of zinc. So once you have all that math figured out, all you have to do is look for the smaller amount of product. This number is smaller, and so that means the reactant that made that is your limiting reactant, meaning it limits you from making any more than that amount. And the amount that you produce, or the smaller amount of product, is also called your theoretical yield. Which is what you calculated. So theoretical yield means the amount that you calculate of the product that you should produce. So we need this information for the next part, percent yield, because percent yield is always going to be actual, or a lot of times this is the given number. So actual yield over theoretical. Which is the calculated number. Times 100. So if we're following the review, if we move into first question 17 says theoretical yield, and we already figured that out and labeled that on the last page. But number 18 says, in this experiment it was carried out, 5.45 grams of zinc were produced. So this is number 18 of your review. So 5.45 grams, that is the given, and that is what actually was produced in the lab. So that's on top, 5.45. Theoretical is what you calculate, and we calculated that before to be 6.036 times 100. And most of the time it should be the smaller number on top and the bigger number on bottom. If you calculate this, 5.45 divided by 6.036, with 3 sig figs, it would be 90.3%. And we know 100% would be a perfect experiment without any error. You should never get above 100%. You should always get something below 100%. The last part is looking at the last question in the lab. This actually goes back to previously when we talked about, in previous units, the law of conservation of mass. And so this table given in balanced equation shows you the mass of all the reactants and products. And so you have to go through to figure out what to put into that box. So we know that the mass of the reactants has to equal the mass of the products. Because you can't create or destroy mass. So if you look, Fe is a reactant, and CuSO4 is a reactant. So these are our two reactants. FeSO4 is a product, Cu is a product, and mass of unreacted Fe, so that means it's left over. And anything that's left over is going to be with the products. So we can separate our table into reactants and products. If you look at the mass of your reactants, 17.1 plus 4.20 equals 21.3 grams. So our reactants add up to 21.3 grams. We said below that mass of reactants has to equal mass of products. So if the reactants equal 21.3, that means the products equal 21.3. And from there you can figure out the missing piece of information. So to calculate how much iron was left unreacted, you know that all of your products have a mass of 21.3 grams, and you subtract out the other two values, minus 18.00 minus 2.5. You should get 0.8 grams. Based on the data table above, what was the limiting reactant? So you have two reactants, you have Fe and you have CuSO4. And you know that the limiting reactant means that it gets used up. So it has to get used up. That means the other thing doesn't get used up. If you look up top, you don't know which one necessarily gets used up, but you know that Fe does not get used up because there's leftover at the end. There's 0.8 grams of leftover. So if Fe has leftover, that means CuSO4 got used up, which means that is your limiting reactant.